Hello everyone. Today we're going to be talking about the AC method for factoring a quadratic expression. Now, the AC method basically uses the concept of factoring by grouping, along with the product of the leading coefficient and the constant term, in order to eliminate the need for guessing and checking when you're factoring. Let's take a look at this example right here. The first step in the AC method is the same as any other factoring method. You're always going to be looking for the greatest common factor first. If there is a greatest common factor, pulling that out is going to make the numbers that we're dealing with smaller and more manageable. So we're going to look for the greatest common factor. Looks like the greatest common factor in this case is 3. Each one of those terms can be divided by 3. So we're going to go ahead and pull out that 3 just like we normally would, leaving me with, that's going to be 10x squared, 81 divided by 3, that's going to be 27. 27x minus 28. Now that I have the greatest common factor pulled out of all that expression, the quadratic that I'm going to be considering is everything right here inside my brackets. We're going to just pretend that the 3 is off on the side for now. The first step when you start the AC method, after you've factored out the greatest common factor, is to multiply the leading coefficient by the constant term. So in this case, I'm going to take that 10, the leading coefficient there right here, and I'm going to multiply it by that constant term, the negative 28. So 10 times negative 28, that is negative 280. What I want to do with that is I want to look for the factor pair of negative 280 that adds up to give me that middle term, the b value, positive 27. Now, because this is a negative 280, I know that one of my factor pairs has to be a positive value and one of my factor pairs has to be a negative value. Because I've got a positive and a negative, when I look for the sum that adds up to give me this middle term of 27, I'm actually going to be looking for the difference between my two factors because one of them has to be positive and one of them has to be negative. And when you add that negative with the positive, you're looking for a difference there. So just like we did with one of the previous factoring methods that we've talked about, we're going to go ahead and list the factor pairs of negative 280. So keeping in mind that it's negative because we're looking for a difference here, I've got 1 and 280. That doesn't have a difference of positive 27. 2 and 140. Still too big. Let's see. 3 doesn't work. 4 and 70. 5's going to be 56. Still, our difference here, the difference between 5 and 56 is 51. We're still too far away from that positive 27 that we're looking for. So we got to keep going. 6 doesn't work. 7 does. 7 and 40. We're getting closer, but we're still not there. And then after 7 and 48, 8 does work. 8 and 35. Now the difference between 8 and 5, that's the one right there. Difference between 8 and 35 is 27. That difference right there is 27. What I'm going to look for, because my 27 here is a positive 27, one of these factors has to be negative, one of them has to be positive. Because the difference that I'm looking for is a positive 27, that means that this 8, the 8 there's got to be the negative one, and the 35 has to be the positive one. Because 8 minus 35, that gives me my positive 27. If it was a negative 27, then those two signs would be flipped. Okay, so now that I've identified that factor pair, I could keep going if I wanted to. Like I could finish listing out the factors of 280, but I don't need to because I already found the factor pair that works. Once I've found that factor pair that works, what I'm going to do is I'm going to rewrite my original expression, this quadratic right here inside the brackets. Instead of having that middle term be the positive 27x, I'm going to rewrite it using the two factor pairs that I found, that positive 8, the negative 8 and the positive 35. We'll just go ahead and keep that 3 on the outside here, just like we normally would. Inside those brackets, we're going to rewrite it so it's 10x squared. Let's see, we'll do the minus 8x plus 35x minus 28. So you'll notice that these two terms right here, this negative 8x plus 35x, they add together to give me that positive 27x. That is the middle term. Now that I have the expression rewritten, the next thing that I want to do is, this is where the factoring by grouping comes in. I'm just going to consider the first two terms, those right there. And I'm going to look for the greatest common factor between those two terms. And then I'm going to look for the greatest common factor between those two terms separately. So let's take a look at that red side, the 10x squared minus 8x. The greatest common factor here of 10x and 8x, that's going to be 2x. And I'm going to factor that 2x out of the 10x squared minus 8x. So that's going to be 5x minus 4. And then I'm going to look for the greatest common factor in these two terms here, the 35x minus the 28. Looks like the greatest common factor there is 7. So I'll pull out a positive 7. I'll write that in green so you know where it's coming from. And then after I factor out a 7 from the 35x, that's going to be 5x. Pull out a 7 from the negative 28, and that's going to be minus 4. Just like that. Okay, after you have factored out the greatest common factor from the first two terms and the greatest common factor from the next two terms, you'll notice something interesting. This expression, what's left over, is the same as what's left over there. If you chose the correct factor pair, regardless of the order that you add those factors in, you're going to get, when you factor out the first two terms and the second two terms, this, what's in the parentheses here and what's in the parentheses here, will be the same two terms. It's going to be the same binomial in both. That just happens to work out because of the way that you use the distributive property when going in the other direction, when you're actually using the distributive property originally. So now that I have both of those terms, because that 5x minus 4 is a term in both of them, I can actually take that 5x minus 4 and I can factor it out of the two terms that are on the inside of my brackets. We'll keep the 3 on the outside of the brackets. That's just your greatest common factor. When I factor out that 5x minus 4, this first term here, if I get rid of the 5x minus 4, the only thing that's going to be left is that 2x. So we write that 2x, right? We'll write that in red so you know that it's the same term. So it's this 2x right there. Then I'm going to do the same thing with the other one. Once I factor out this 5x minus 4, the only thing that I'm going to be left with is that positive 7. That's going to be plus 7. Now I actually have my factored expression. It's right there. That's it. It's 5x minus 4 times 2x plus 7. But before I move forward, I want to make sure that those factors, they actually multiply together to give me the thing that I started with, this 10x squared plus 27x minus 28. I want to make sure that those two things match up. So in order to do that, I'm going to check my work using just by using the distributive property. So I'll FOIL this here. I've got my first terms. It's going to give me my 10x squared. I'm going to do my outside terms. That's going to give me, well, let's see, 7 times 5 is going to be plus 35x. Then I'll do my inside terms. So I get negative 4 times 2x. It's going to be minus 8. Then I'll do my last terms here. And that's going to give me my, that's a minus 28. And you have the 35x minus 8x. That does, in fact, equal the original 27x that we were looking at, giving you 10x squared plus 27x minus 28. Because I know that I just expanded that, I just FOILed that expression, and I know that I got the original that I started with, I know that my factored form is correct. Rewriting this with the greatest common factor on the outside, it's going to be 5x minus 4 times 2x plus 7. And that is the final factored form of your expression.